Hello students, welcome to chemistry class. Today we are going to discuss about the diazonium salts. Let us see what are diazonium salts. So these diazonium salts are represented by the general formula, that is R N2 plus and X minus. So this R stands for aryl group, and this N2 plus is to be called as diazonium group, and this X minus may be Cl minus, Br minus, or HSO4 minus, or BF4 minus, and etc. So the diazonium salts are represented by the general formula, that is Rn2 plus and X minus. So that R groups are generally aryl groups, and this aryl group attached to the N2 plus, that is N2 plus is to be called as diazonium group, and it is X minus. So X is either halogens or any one negatively charged particles. So they are named by suffixing diazonium to the name of the parent hydrocarbon from which they are to be formed, followed by the name of the anion such as chloride, hydrogen sulfide, etc. For example, let us take R is C6H5 and it is N2 plus and Cl minus, and one more molecule C6H5 and it is N2 plus and HSO4 minus. So these diazonium salts are generally named by suffixing diazonium to the name of the parent hydrocarbon. So here the parent hydrocarbon is benzene ring. So to the benzene diazonium word is added and followed by the name of the anion. So here the name of the anion is chloride, that is benzene diazonium chloride. And in the second molecule, that is C6H5, is to be called as benzene, and the word diazonium is to be added, azonium, and anion is to be represented as hydrogen sulfate. That is, first to write the name of the hydrocarbon, then attach the word diazonium, and then write the name of the anion. So that compounds are generally to be called as diazonium salts. And let us see the stability of the diazonium ions. So the primary aromatic amines, form arene diazonium salts. So these arene diazonium salts are to be generally prepared from the primary aromatic amines, which are stable for a short time in solution. In solution, they are stable for a short time at low temperature, that is temperature is 273 to 278 Kelvin. And the stability of the arene diazonium ion is explained on the basis of resonance structures. Let us see the resonance structures of arene diazonium salts. That is, it contains alternative single bonds and double bonds, and N2 group, N triple bond N, and this nitrogen contains 2 lone pair of electrons, and because of the presence of 4 bonds to the nitrogen has positive charge. So this double bonded electrons present in the benzene ring undergoes delocalization, that is, it is shifted towards the positively charged nitrogen, and these triple bonds are to be shifted to the nitrogen. So the resonance structures of these diazonium salts are entirely different as compared to the phenols and for the amines. So the double bonds shifted towards the nitrogen, so it is double bond N and it is double bond N, so it contains only 2 lone pairs and there is one extra electrons on the nitrogen and the positive charge on the nitrogen and the remaining 2 bonds, and this carbon loses electrons, so it gets the positive charge, and the double bonded electrons in the benzene undergoes delocalization, so it gives, so it is double bond and it is double bond and this carbon loses electrons, so it gets positive charge and it is double bond N and 2 pairs and 1 negative charge and 1 positive charge. So in order to satisfy this positive charge, the double bonded electron shifted to the next carbon, so it gives double bond and it is positive and it is double bond N plus and double bond N minus, right? And finally the electrons are to be shifted to the nitrogen and these electrons are shifted towards the carbon, so it gives the original structure, that is double bonds and it is double bond, so it is single bond N plus and 3 bonds N lone pair of electrons. So these are the resonance structures of the arene diazonium salts, and the resonance stabilization is not possible in diazonium salts of aliphatic amines. So aliphatic amines means that is alkyl or aryl groups attached to the diazonium group. So in this molecule there is no resonance structures, that is resonance structures are not possible. Next, let us see the methods of preparation of diazonium salts. So this benzene diazonium chlorides or halides are generally prepared by the reaction of aniline with the nitrous acid, that is C6H5NH2, that is to be called as aniline. So this aniline reacts with the nitrous acid, that is nitrous acid is the mixture of sodium nitrite and hydrochloric acid, and the reaction takes place at 273 to 278 Kelvin because these diazonium salts are stable only at this temperature. So above this temperature these diazonium salts are not stable, so it gives the product, that is C6H5N2 plus and Cl minus is obtained, and there is an elimination of sodium along with the Cl, so it is NaCl plus H2O. So on balancing the chemical reaction, it requires 2 moles of Cl and it requires 2 moles of water molecules. So this is the method of preparation of diazonium salts, or this reaction is also to be called as diazotization reaction. Next, let us see the physical properties of diazonium salts. So these are natural compounds with the pleasant odor, that is the smell of the diazonium salts are pleasant and similar to the bitter almonds, and these are generally soluble in water as well as in the organic solvents. So the diazonium salts are generally soluble in water as well as in the organic solvents, and these are poisonous but less than HCl. Generally these diazonium salts are poisonous, but the poisonous nature is less than the hydrogen cyanide. So that indicates that hydrogen cyanide is more poisonous as compared to the diazonium salts. So these are the physical properties of diazonium salts. And let us see the chemical reactions of diazonium salts. Generally, the reactions of diazonium salts can be divided into two categories, namely the reaction involving the displacement of nitrogen and the reaction involving the retention of diazo group. So in the first reaction, there is a displacement or replacement of nitrogen or diazonium group, and the reactions involving the retention of diazonium group. Let us see one by one what is this displacement of nitrogen and what are the reactions involving the retention of diazonium group. So in that first one, that is reactions involving the displacement of nitrogen. So this diazonium group, being a very good leaving group, is subjected by the other groups such as chlorides, bromides, iodides, cyanides, hydroxyl groups. That is, as compared to the halides and cyanides and hydroxyl groups, this diazonium group is a very good leaving group from the aromatic ring, because the nitrogen thus formed escapes from the reaction mixture as a gas. Let us see the first reaction involving the displacement of nitrogen, that is Sand-Meyer's reaction. Very important for 2 marks. So the Sand-Meyer reaction, so the aromatic diazonium halides Ar, N2 plus and X minus, that is to be called as diazonium salts. So this diazonium salts reacts with the CuCl in the presence of HCl, or CuBr, cuprous bromide, in the presence of HBr, or CuCyanide, cuprous cyanide, in the presence of KCl. So in all these reactions, N2 gas is to be eliminated as a byproduct, and the aryl group combines with the halides, that is ArCl, and here Ar combines with the Br and Ar combines with the Cn, plus nitrogen gas is to be eliminated as a byproduct, because nitrogen is a better leaving group as compared to the halides, cyanides and hydroxyl groups. For example, let us say C6H5 N2 plus and Cl minus. So it is to be called as benzene diazonium chloride. So this benzene diazonium chloride reacts with the CuCl in the presence of hydrochloric acid. So it gives the product, that is C6H5. Here the halogen is Cl plus nitrogen gas is to be eliminated. Or this C6H5 N2 plus and Cl minus reacts with the cuprous cyanide in the presence of potassium cyanide. So it gives the product, that is C6H5 combines with the Cn plus the byproduct is N2 gas. Next, let us see the second reaction involving the displacement of nitrogen, that is GATTERMAN's reaction. So in the GATTERMAN's reaction, that is the aromatic diazonium halides, that is Ar, N2 plus, X minus. So it reacts with the copper in the presence of hydrochloric acid, or copper in the presence of HBr. So in the Sand-Meyer reaction, cuprous chloride in the presence of HCl is to be treated with the diazonium salts. In the GATTERMAN's reaction, So the aromatic diazonium halides reacts with the halogen acids in the presence of copper powder. In the presence of copper powder. So it gives the product, that is aryl group combines with the Cl. So it gives ArCl plus nitrogen gas is eliminated, and this copper combines with the X, it gives CuX. And in the presence of HBr, so it gives the product ArBr plus nitrogen gas plus CuX. So the yield in Sandmeyer reaction is found to be better than GATTERMAN's reaction. That is, the percentage of yield in the Sandmeyer reaction is found to be better as compared to the GATTERMAN's reaction. For example, let us take C6H5N2 plus and Cl minus. So it reacts with the copper in the presence of hydrochloric acid. So it gives the C6H5Cl chlorobenzene plus nitrogen gas plus Cu, halogen is Cl, and C6H5N2 plus and it is Br minus. So it reacts with the halogen acids, that is HBr, in the presence of copper. So it gives the product C6H5Br plus nitrogen gas plus CuBr. So chlorobenzene and bromobenzene is to be obtained by the reaction of benzene diazonium salts with the halogen acids in the presence of copper. And in the next class, let us continue the remaining reactions of diazonium salts.